Okay, so my talk is called Modernising Our Application with TypeScript. Has anybody used TypeScript in the audience? Show of hands. That's fewer than I thought actually. Well then I guess nobody's... Have you tried to sort of port an existing JavaScript application into using TypeScript? No. That's what this talk's about. So we've got this application here. It's the MyBets product. It's basically, if you place a bet with Skybet, you go into MyBets and you can track all your bets. So it was initially just designed for football. So you could go in, see all your football bets, Man United to win, Leeds to win and all that. And like when the goal goes in, it'll update in there and it'll tell you all the scores and stuff like that. Since then, it's been sort of evolved. We've added new sports like horse racing, golf, and pretty much every bet is now in there. So it's not the same product it was initially designed to be. From a technical point of view, it's just got a PHP API and a React.js JavaScript. This talk is just about sort of like the React.js application. So why did we want to use TypeScript? Basically, we had a 2 to 3 year old code base. We were using it every day. We didn't really have any problems with it, but we were just sort of concerned that if we just keep plodding along, keep adding stuff, we might fall into the trap of it becoming legacy code. We wanted a better way to model the structure of our bets. So bets are quite complicated these days. Bets have multiple selections, outcomes and everything, and they've all got different types, and basically it's a big complex object. So we wanted a much more powerful tool than just sort of ES5 JavaScript to sort of model that. The devs wanted stuff like interfaces, generic stuff that they were used to with sort of using PHP but couldn't really use or take advantage of in JavaScript. TypeScript gives you those things. And adding type hints to the code not only helps developers understand what's going on, but then you've also got the static analysis tools such as the TypeScript compiler, which are going to, if you write some code and say this is a number and then you try and compare it to a string or whatever, it's going to tell you straight away that you've made a silly mistake, rather than that code getting pushed to production and maybe you don't test that use case or whatever. So it lets you know ahead of time whether you've actually done anything silly. So off we go to the TypeScript website, and this is my favorite quote from the TypeScript website. Basically, TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. So I've read something like this before. Has anybody used Sass? Yeah, few more people. So I've converted projects from CSS to Sass before, and Sass use exactly the same words. It's like SCSS is a superset of CSS. And what you can do, you can take your CSS files, rename them to .scss, run them through the compiler, no problem whatsoever, and then you can start building on top of that and adding all the like cool Sass features. So I thought, yeah, great, we'll do that with TypeScript, change all of the JavaScript files to .ts, and then we'll add all our nice sort of TypeScript stuff, which is great. So I'm going to talk about some of the cool things you can do with TypeScript. This is a class in TypeScript. It's fairly similar syntax to ES6 because it is a superset. It's got a couple of extra things though. So you can see like the visibility on the arguments here. That's just sort of like a shorthand way of saying, well, if you've got them on the constructor, it's a shorthand way of saying when this class is instantiated, set ID as public with whatever's passed in as that ID param. And it just saves you having a constructor full of this ID equals this.id equals ID. And then after the arg, so the arg is ID and it's of type number. So that means you can only pass in a number to that argument. And you can see down here actually, so I've just instantiated a new bet object, and you've got event and ID, which are there as sort of autofill because they're the public parameters there. Interfaces, so the interface in TypeScript aren't the same as they are in sort of normal or other OOP languages, in the sense that you don't need to implement the interface, you just need to have the same shape as the interface. So we've got here a function called printBet, which takes an argument myBet of type bet, which is just that interface up there. And on line 10, we can just pass in a blob of JSON pretty much. And because that's got a stake, which is a number, and returns, which is a number, that matches the interface up there, so it's happy with that. That's fine, but then if you try and pass in a bit of JSON down there where the returns is a string, TypeScript's going to go, whoa, what are you doing? Stop right there. I'm having none of that because it's not a number, and that's why TypeScript's good. So You can use interfaces like that. You can also use them in the same way you probably used to with other OOP languages. So you can have a class down here which implements an interface. This one here doesn't, because this class doesn't have the stake and the returns as a number. So again, TypeScript will tell you, no, you can't do that. Generics, I'm not going to go into too much detail about what they are or how they work, but for me, this is a sort of main benefit of the React integration with TypeScript. So you've got your class, extend React component, and then this sort of bit here is the generics. So you can specify what your props look like and what your state looks like. And what that means is anywhere in your React class, you can do this.props, and it knows that props looks exactly like the interface up there. Similarly for stake, obviously, and then within that class, it can reason about your code. So there I've tried to compare a number to a date, which is just not going to work. So it'll tell me that I've done something stupid. So now we know that TypeScript's going to solve all of our problems. Back to the job at hand, we had an application. We wanted to refactor the whole code base, just because we wanted static analysis across everything. Otherwise, what's the point really? We had a business critical application, so it's used millions of times over the weekend. If we mess this up, our customers are going to notice, and they're going to say some nasty things about us on Twitter. And obviously that's sort of painful to read, but this is like a product that customers go and they expect to be able to use, because they're staking their own money. They want to be able to go on, see what they've bet on, and be able to cash it out. It's really important to them. So we've got a JavaScript application, and out the other side needs to be TypeScript, but it needs to be 100% functionally equivalent. Customers can't know any different. So this was our basic setup beforehand. So we've got JavaScript application code up here, node modules there. We feed this into Gulp, which is our sort of like build process. We use Babel. That's just a sort of transpiler. Transpiles from the React JSX code, and it just outputs plain JavaScript. Webpack sort of put it all together, and then out comes a single JavaScript artifact. So the plan is change the application code to TypeScript. Can't use Babel anymore, but we've got to use TS Loader, which is just, it's similar job to Babel, but it converts from TypeScript to JavaScript. But the Gulp thing takes exactly the same input, and it comes out with the same JavaScript artifact. So I'll come back to this. TypeScript is a typed superset of JavaScript that compiles to plain JavaScript. We've just changed all of our JavaScript files to .ts, and we run the compiler for the first time, and I'm literally just expecting the same sort of experience as with Sass, maybe like a few little things. What we got was this. It's not really important what those errors are specifically, but there were a lot of them. I did a Control F on error in capitals, and there were 1,800 errors in total to sift through. So yeah, that was quite a lot, and it seemed quite a daunting project at that point. So what do we do to sort of get rid of that mountain of errors? First thing we did was convert all of our classes from the ES5 JavaScript to ES6. That was mainly just to take advantage of sort of the React integration that I was talking about with the props and stuff like that. It's a React application, most of it's component based, so we're going to get the most benefit from using that. A lot of the errors beforehand were just because we had methods which were calling statically which weren't defined statically, which for TypeScript didn't like that. TypeScript's super strict, which is its strength really. It'll tell you if you've done something which isn't quite right. So we had to go and fix all of those. TypeScript actually plays quite nicely with JavaScript modules, so if you use TypeScript, you're not sort of tunneled into just using TypeScript modules. You can still go and npm install a purely JavaScript package. You've just got to provide it with type definitions, which basically tell the TypeScript compiler what the sort of JavaScript looks like in a way that TypeScript can understand it. So for most things, so like React, you can just npm install @types React, @type sort of any package name really. But for the ones which don't have those definitions, you've got to write your own. But again, that wasn't too much of a pain point. So we've done all of that. We're happy. We've converted our app to TypeScript. It compiles fine. Everything's good. The problem was And this is a pretty simplified view of our sort of branch instruction, like release process. The TypeScript branch down here, this had sort of lasted maybe about a month or so, and this product is being developed on all the time. We're getting feature requests in from all sorts of people. So there's quite a few features that have been developed here and gone back into master, but they've just been developed in JavaScript. So we can't just merge the TypeScript branch straight back into master, because then you're going to get some weird sort of JavaScript TypeScript conflict. So we had to pause development of sort of all the JavaScript features, merged master with all the new features back into the TypeScript branch. We then had to make everything TypeScript. We had to TypeScript all of the JavaScript features again, but that was quite a small task considering we just converted the whole application. There were maybe like 4 or 5 different components and some stores and stuff like that which needed changing, but the actual sort of volume of the task was quite small in comparison. Going back to the previous slide where we had the sort of build process with gulp, because we were using the same inputs and outputs, that was then super easy to pass off to our CI pipeline to build, because it doesn't really care. So we use Jenkins to sort of build all of our applications and stuff. So Jenkins only cares that it can run gulp, and it's got some arguments to gulp. But as long as those arguments are the same and a singular sort of singular JavaScript artifact comes out of that, that's fine. It doesn't care. It can run it. So that was pretty pain-free. And then off we go to live. So this is what it looked like in JavaScript, the JavaScript implementation, and that was the one in TypeScript. I've got to admit, these are actually slightly fabricated. It's just a copy and paste. But the point is that we managed to success through a lot of sort of like regression testing and stuff like that. We did actually make sure that it was functionally exactly the same, and no customer sort of noticed anything had happened. But obviously our developers were happy because they could use all these shiny new features of TypeScript. And that concludes my talk. Thank you.